Batteries are an essential need at this point. We have batteries in almost everything, from phones to cars to laptops we use for work. But for over 3 decades, we've been using the same battery technology, and we know that this technology isn't going to stay the same forever. So why have we kept that? In this video, we'll be diving into why our current batteries won't last forever, and why a revolution is a must. So stay tuned.
In 1936, a strange pot was dug up in a tiny town close to Baghdad, Iraq, and for 2 years this pot was simply another dusty, unremarkable exhibit in a museum. But one man saw things differently. The moment Austrian archaeologist Wilhelm Koenig laid eyes upon it, he knew that there was something remarkable hidden inside it. And he was correct. This boring-looking pot turned out to be the oldest man-made battery, made over 2,000 years ago. This pot, now known as the Baghdad battery, is a simple clay pot with an asphalt stopper stuck inside of it, an iron rod encased in a copper coil, and an acidic residue, suggesting that they used grape juice in the paving. But even so, this battery wasn't all that powerful and could barely give an output of 1 volt, meaning that to charge an iPhone, you'd need 2,000. Now compare that to your charger. The most logical use for this battery is electroplating little items with thin layers of copper for decoration. However, the underlying idea of this antique battery has stayed unchanged throughout the years, and it is the same principle that basically powers modern electronics. Batteries, in essence, consist of 2 electrodes, positive cathodes and negative anodes, connected by an electrolyte, which is frequently a liquid gel or paste and allows ions to move between the 2 electrodes. Now, compare that to modern batteries, nothing much has changed. The cathode remains the copper cylinder, the anode is the iron rod, and the electrolyte remains the grape juice. There's a cathode in the lithium battery that powers your laptop, and graphite is typically used as the anode in lithium metal oxide batteries, while a solution of lithium salt serves as the electrolyte. Although there have been many improvements made through the years, the underlying ideas have been the same. Alessandro Volta, an Italian physicist, constructed the first modern battery in 1800 by building a voltaic pile out of alternating zinc and copper discs separated by brine-soaked cardboard. This made it the world's first continuous electrical battery. Wires were attached to the top and bottom of Volta's pile, which generated a constant current of electricity. In 1859, it was taken a step further with the invention of lead-acid cells by French scientist Gaston Plante, making it the first rechargeable battery. Later on, at the end of the century in 1899, scientist Waldemar Junger from Sweden constructed the initial cadmium battery. After these incredible achievements, the battery didn't see any breakthroughs for 70 years. When ExxonMobil patented Michael Whittingham's lithium battery in the 1970s, it revolutionized many industries. Not only did the battery have all the features of previous batteries, but it could also deliver a high voltage, making it the bedrock of most current batteries. But still, even though the lithium battery is adequate, it just falls short. We can certainly create larger lithium batteries, but there's a theoretical limit of 260 wattage-hours per kilogram of host battery weight that scientists have determined. Considering that the average of earlier battery technologies was about 75, that is quite good. What this means is that if a phone runs a full day on one charge and the company wants to extend the battery life to a week, they'd have to use a battery that's 5 times heavier, maybe even more. However, there is a second, more hidden obstacle to creating larger and better batteries, one that tech companies would rather not bring up in any conversation, despite its importance. The resources needed to manufacture batteries are becoming increasingly scarce, as confirmed by scientists. There are 3 main ingredients needed to create different types of batteries: lithium, nickel-cadmium, and lead-acid, all of which are limited natural resources, and there isn't a magical way to create batteries out of thin air. We need a lot more of these rare earth materials if we want to start a battery revolution, and our current system isn't sustainable enough for it. Orchids are notoriously hard to find, and their mining is notoriously dangerous, energy-intensive, harmful to the environment, and often uses child slaves in unhealthy, dirty conditions. So what could be the next step in battery advancement? New battery technology aims to increase energy density while decreasing charging time, and if scientists are able to achieve this, it will revolutionize the industry. And that's where solid-state batteries come into play. In contrast to conventional batteries, these replace liquid electrolytes with solid ones, specifically ceramic. Not only is it ideal, since ions may flow freely through it due to its high conductivity, but the main benefit will be an increase in security. Two deadly defects exist in today's batteries. A thermal runaway, which can cause fires or even explosions, is a first concern, and another issue with lithium-ion batteries is the formation of dendrites, which are actually strands of lithium metal that develop within the electrolyte itself. And if the dendrites grow to the size where they obstruct the cathode-anode gap, well, we have another concern of fire or terrible explosions. Now, if you use a solid-state battery, both of these concerns just vanish. No longer is thermal runaway a concern. Solid dendrites will have a hard enough time penetrating the electrolyte, and ceramic is chemically inert and very stable at high temperatures. Since solid-state batteries do not have a permanent anode, they're about 50% of the weight of lithium-ion batteries, which allows them to boost energy densities that are around 100% higher. Now, imagine these batteries in cars. If that were to happen, the range anxiety argument against electric cars would become irrelevant, as a vehicle with the same weighted battery as today's 350-mile EV would have a 700-mile range. But even if this all sounds promising, further development is necessary to ensure the stability and consistent operation of solid-state batteries. However, American company Quantum AP is presently at the forefront of this field. And you can expect to see solid-state batteries in consumer electronics and automobiles by 2025, according to current predictions. But that's getting into a whole different category of batteries. What if we can find a less complicated way to improve our existing batteries? Imagine if there was a simple way to improve the performance of lithium-ion batteries by substituting a more abundant, less expensive mineral for cobalt, one of their main ingredients. I mean, about 118 recognized elements can replace cobalt, so there's got to be one that reduces the risks of fires and explosions, right? Well, we have sulfur. Because of its low density and high lithium-ion capacity, sulfur is an ideal cathode material. In contrast, existing lithium batteries have an energy density of 260 wattage kilograms, while prototype sulfur batteries have shown 550 wattage kilograms, and it's probable that this number will rise as research progresses. Cobalt and nickel, the two elements utilized in lithium-ion batteries, are extremely rare and difficult to extract. Sulfur, on the other hand, is both inexpensive and abundant. In fact, it's the 10th most abundant element in the universe by mass. Some labs have already constructed sulfur batteries that are both functional and economically practical. In fact, scientists have been exploring the idea since the 1960s, and we're quite far along in our present revisions. But even so, we don't see them commercially available anywhere. Commercially viable isn't often a precise description, and the present iteration has extremely short lifetimes when subjected to a charge and discharge cycle. Some prototypes have shown 10 to 30 charge cycles before completely dying. I mean, you're not going to purchase an electric vehicle within a 1,000-mile range if it can only be charged 30 times. Improving upon these shortcomings is currently a top priority, and within the last year, several lithium-ion batteries with lifespans in the hundreds of cycles rather than the tens have been manufactured. Lighten, a venture capital-backed firm based in San Jose, California, is constructing an automated production line to manufacture lithium-ion batteries. The company's principal customers are electric vehicle manufacturers. If the company manages to reach its goal, it would be the beginning of a portable energy revolution, and it would be quite exciting. But how long until we see these technologies implemented in everyday life, in areas like our homes and offices? Well, according to the predictions, we'll see these batteries in phones and cars this year. For almost 3 decades, we've relied on the same battery technology. The search for a more cost-effective, lightweight, and energy-dense substitute has been incredibly challenging, but once we succeed, it would be an understatement to claim that everything will be changed forever. If we could create energy-dense, inexpensive, and efficient batteries that a remote village could charge with solar energy, then everyone there could have access to a constant, uninterruptible supply of almost free power for the rest of time. Furthermore, this new battery technology can help communities grow, which in turn helps fund infrastructure upgrades for the grid. But what do you think? Will we ever truly get batteries that will outperform lithium-ion batteries available for common customers? Let us know in the comments below.